In this video, we're going to focus on compound probability, but particularly of independent events. So let's say we wish to find a probability of two events occurring. Let's say event A and event B. If these events are independent, then the probability of these two events occurring is simply the product of the probability that event A will occur and then event B will occur. So let's keep that in mind. Now let's focus on this question. What is the probability of getting heads twice after flipping a coin? So we need to get heads on the first try and then heads on the second try. So the probability of getting these two events is going to be the probability of getting heads on the first try times the probability of getting heads on the second try. So what is the probability of getting heads just by flipping one coin? Well, if we write out the sample space, there's only two options. Either we get heads or tails. So the probability of getting heads is going to be this one option out of the two possible options. So it's 1 out of 2. Now, for the second event, the probability will be the same. It's also 1 out of 2. 1 times 1 is 1, 2 times 2 is 4. So the probability of getting two heads is 1 out of 4. Now, to confirm this answer, let's write out the sample space for flipping two coins. We can get heads and then heads, or we can get heads then tails, or we can get tails first and then heads on the second try, or we can get two tails. So notice that we have one event that is our desired event out of a potential of 4 events. So that's why the probability is 1 out of 4. Out of the 4 events, only one leads to a successful outcome, the outcome that we want. And so that's one way in which you can confirm that answer. Now, what about part B? What is the probability of getting heads, tails, heads after flipping a coin 3 times? So what you need to know is that the order matters in this problem. But getting the answer is pretty straightforward. So HTH, this is going to be the probability of getting heads on the first try times the probability of getting tails on the second try times the probability of getting heads on the third try. And so for each of these events, the probability of them occurring is 1/2. So this is basically 1/2 raised to the third power. 2 to the third is 8, and 1 to the third is 1. So the probability of this happening is 1 out of 8. Now let's confirm it. Let's write out the sample space for flipping 3 coins. So we can get all 3 heads, or it could be heads, heads, and then tails, or it can be HTH, or HTT, THH, and so forth. So these are the 8 possibilities that we can get when flipping 3 coins. So notice that there's only one out of these 8 possibilities that leads to the event that we want. And so that's why the probability is 1 out of 8. Now let's move on to part C. What is the probability of getting 2 tails and 1 heads? So does the order matter in this problem? So looking at the 8 options that we have here, which one contains 2 tails and 1 heads? I'm going to highlight it in red. So this has 2 tails and 1 heads. So there's this one and that one as well. So therefore, the probability of getting either HTT or THT or TTH is 3 out of 8, because we have 3 favorable outcomes out of 8 possibilities that will lead to this event. So you need to be careful if the order matters or if it doesn't. So for this problem, the order matters, but for the second problem, the order doesn't matter. So it's good to list out all the potential events that would lead to this particular situation. Number 2, in a standard 52 card deck, what is the probability of selecting a queen? Well, before we go into this question, let's talk about some things you need to know. So in a standard 52 card deck, you don't have any jokers. The first type of card that you have is the red diamond. The second card is the red hearts. The third one, which is going to be black, but I can't use black on a black screen, so I'm going to use white instead. The third one represents the spades, which looks something like this. My drawing's not perfect, but what you can do is go to Google Images, type in standard 52 card deck, and you'll see all the cards in the 52 card deck. But this is supposed to be black instead of white. Just keep that in mind. The last type is the clubs, which looks something like this. Let me see if I can draw that better. But it's something like that. You'll see it when you search it on Google Images. Now, for each of these 4 different types of cards, you have the ace, and then you have the numbers 2 all the way to 10. After 10, you have the jack, and then the queen, and then the king. So this right here represents 13 cards. So what this means is that there's 13 diamonds, 13 hearts, 13 spades, and 13 clubs. 13 times 4 gives us the total of 52 cards. So there's 2 types of cards that are red. 13 times 2 is 26. So there's 26 red cards, and there's 26 black cards. So these are some things to know if you're dealing with a probability question using cards. So let's begin. You may want to write those things down as notes to answer these questions coming up. So in a standard 52 card deck, what is the probability of selecting a queen? So how many queens are there? So we have the queen of diamonds, the queen of hearts, the queen of spades, and the queen of clubs. So there's only 4 types of queens because there's 4 different types of cards. So there's 4 queens out of a total of 52 cards. 4 is 4 times 1. 52 is 4 times 13. So we could cancel a 4, and so the answer is going to be 1 out of 13. 1 divided by 13 is basically 0.07692. That's a rounded answer. So if you multiply that by 100, the probability is approximately 7.69%. Now, what about part B? What is the probability of selecting a black card that is greater than 3, but less than or equal to 9? So let's write out the list of numbers that fit these characteristics. So let's say that X is basically the number of a card that we're going to pick. It's greater than 3, but less than or equal to 9. So this does not include 3. So if we write the sample space, this is going to be 4, 5, 6, 7, 8, 9. Now you might be thinking, okay, so the probability is going to be 6 out of 52. But keep in mind, there's 2 types of black cards. You have the clubs and you have the spades. So there's 6 black clubs with these numbers, and there's 6 spades with those same numbers. So really, there's 12 cards that is between, that's greater than 3, less than or equal to 9, that is a black card. Because you got the clubs and the spades. So it's 12 out of 52. 12 is 4 times 3, 52 is 4 times 13. So if we cancel a 4, the probability is going to be 3 out of 13. This is the answer for part B. Now let's move on to our last question. or rather, the last part in this question. Part C. What is the probability of selecting a red queen on, not a red queen, but a red king on the first try, and then a diamond card on the second try without replacement? Now, this problem is a little bit tricky, so go ahead and try it. Now, what we don't want to do is this. We don't want to say it's going to be the probability of selecting a red king times the probability of selecting a diamond, because the first event is going to affect the second event. For instance, let's say if we want to find the probability of selecting a red king, there's 2 red kings out of 52 cards. You could have the red diamond or the red king of hearts. Now, the probability of selecting a diamond without replacement, we took out a card, so there's 51 cards left. Now, how many diamonds are left? Now, the number of diamonds that are left depends on which red king that you selected. If we selected a red king of hearts, then there's 13 diamonds left, including the red king of diamonds. But if on the first try we selected the red king of diamonds, then there's 12 diamonds left. So these are dependent events. The second event depends on the first event, so we can't use this equation for this particular situation. Now, another formula that we could use is when you have an OR situation. The probability of selecting A or B is equal to the probability of A plus the probability of B. We're going to have to use this. So event A is going to represent the first situation. That is, let's say if we select a red king of hearts. And then on the second event, we'll be selecting a diamond. Event B will be selecting a red king of diamonds. And then the second event will be selecting another diamond card. So let's start with the first event. This is going to be the probability of getting the red king of hearts times the probability of getting a diamond card. So we know that there's 4 red kings. There's 4 king cards. 2 of them are red, the diamonds and the hearts. So to get a red king of hearts, there's only 1 red king of hearts out of 52 cards. So the probability is 1 out of 52. Now, to get a diamond card after that, once we take out the red king, there's going to be not 52 cards in the deck, 51 cards, because this is without replacement. We're not putting the red king of hearts back into the deck. So now we have 51 cards to choose from. 13 of those cards are diamonds. So now let's do the math. 52 is basically 4 times 13. So we can cancel a 13, and 4 times 50 is 200, so 4 times 51 is going to be 204. You just add another 4. So the probability of getting a red king of hearts and then a diamond card is 1 out of 204. Now let's focus on the other events, event B. So this is if we get a red king of diamonds. Let me put the probability of getting a red king of diamonds times the probability of getting a diamond card. So there's only 1 red king of diamonds out of the 52 cards. Now this is without replacement. Once we take that card out, there's 51 cards left. Now, there's 13 diamond cards. We took out 1 of the diamond cards, so there's 12 diamond cards left over. So the probability for the second event is going to be the 12 diamonds out of the 51 cards that remains. 52, we're going to say it's 4 times 13. 12 is 4 times 3. 51 is 17 times 3. So we're going to cancel a 4, and we're going to cancel a 3. So what we have on the bottom is 13 times 17. 13 times 17 is 221. So the probability of selecting a red king of diamonds on the first try and then a diamond card on the second try without replacement is 1 out of 221. Now let's put all of this together. So the probability of getting a red king followed by a diamond card is the sum of the probability of getting a red king of hearts, because that is a red king, followed by a diamond card, plus the probability of getting a red king of diamonds, which is still a red king, followed by a diamond card. We had to break up this problem into these two situations because the probability for those two situations are different. So this is going to be 1 over 204, and then the other one is 1 over 221. So we need to get common denominators in order to add these two fractions. Let's multiply the second fraction by 204 and the first one by 221. 204 times 221 is 45,084. And then we could add 221 plus 204, which is 425. Now, we can probably simplify our answer somehow. These are some large numbers, so this is... Let's take a step back. Perhaps it's better if we simplified it from the beginning. Now 221, that's basically, we said that was 13 times 17. 204 is 51 times 4. Now 51, we can break that into 17 times 3. So 17 times 3 times 4, that'll give us the original 204. So now we need to get common denominators. We already have a 17. This has a 12, that's 3 times 4. So we need to multiply the fraction on the right by 12 over 12. The fraction on the right has a 13, which the left one, or the one on the left, doesn't have. So we're going to multiply the fraction on the left by 13 over 13. So this should give us common denominators that are less in value than what we had before. So 13 times 17 times 3 times 4, that's 2,652. 13 times 17 times 12 is the same thing, 2652. So now we can add 13 plus 12, which is 25. So this right here is the final answer, 25 over 2,652. That is the probability of getting a red king on the first try and then a diamond card on the second try without replacement.